These are the solutions for assignment 13 in test prep, dealing with descriptive statistics calculations, things like the mean, median, and mode. And this is by far the more important of the two assignments, although the second assignment is really good just for informational and knowledge purposes. So if you had a question on the SAT, it's likely going to involve a question over the mean and perhaps the median, and looking at a statistical display, we'll call it. A vast majority of these questions are questions on means and weighted means. So what does it mean to be a weighted mean? We'll get into that as I go through these. So question one, very popular question, the most popular question. What does the next score have to be to make my average usually go up? So in this case, go up to 54. So it's the sum anytime you do the mean over the count. So we're trying to figure out what X is. My advice on the test is to, start with 74, add up all of those with 74, and then divide by 5. You'll see that that doesn't work, and then just go to the next highest one. Because usually people want to raise their average rather than lower it. And so why not just do a guess and check, pick the highest one, and then go. The average of 3 consecutive numbers starting with x minus 4 is which one of the following? Okay, so you need to know what consecutive numbers means. This is great for pick a number for x. So let's say we pick x is 7. So that means that's 3. This is 6. This is 5. This is 4. And that's 3. So starting with 3, and we want 3 consecutive numbers, that means we're doing 3, 4, and 5. So you see the average is 4. So a lot of times picking numbers really can help with these. Problem 3, the average of 3 numbers is 5, so why not just call them all 5? What does the next one have to be to make 7 your average? Well, that's a pretty big jump, actually. And so that next one is going to have to be a 13 to do it. All right, so here, I kind of really made this more difficult than it was. The average of 6 numbers is 15. So their sum is 90. That's right here. When one of the numbers is removed, the average is 10. So now the sum is 10 times 5, which is 50. Okay, so what is the value of the number that was removed? So the new sum is 50. I don't have that anywhere, but we'll put it right here. So it must be that you removed a 40. So you're just really doing the count times the sum. So again, 6 numbers, if their average is 15, 15 times 6 is 90. That's what the sum's going to be. 90 over 6 is 15. And then you pull one out, the average is 10, so 10 times 5, that sum is 50, then find the difference. Number 5, what I've been waiting to get to. Okay, this is called a weighted average, and it takes place so often in society, especially with teachers doing their grades. Like we want to weigh our quizzes 70% in the class or something like that. So it's frequency times weight, frequency 1 times weight 1, plus frequency 2 times weight 2, on and on, over the sum of the frequencies. And all of your weights should add to 1, but I guess that's not really the intention here. Strike that. But anyway, frequency times the weight plus frequency 2 times weight over the sum of the frequencies. So we have 50 ducks that weigh 5 pounds each. So are we going to do 5 plus 5 plus 5 50 times? No, we're just going to do 50 times 5. and we have 40 ducks that weigh 8 pounds. And then add the frequencies, so being 90 ducks. So average weight is 6.3 repeating pounds. Same thing here, frequency times weight plus frequency 2 times weight 2 over the sum of the frequencies. 2.3 repeating cars, average number of cars there. Okay. Problem 7. The average of 3 numbers x, y, and z is m. So I did this here. 3m is the sum. The average of 2 other numbers, y plus z over 2 is n. Okay, so there's 2n is the sum there. What is the value of x in terms of m and n? So certainly you can pick numbers for all of these, but don't do that. Just take, y plus z is 2n, so you put that in for y plus z. So x plus 2n equals 3m, then solve it. You can play the numbers game, but that's pretty hard to do. But this is, I like this because this is what the SAT just really loves to do. Crazy stuff with statistics. So A over B is 1/4, and C over B is 3/4. What's the average of A and C? So you got to solve for A and C. And so A is B over 4, multiply both sides by B, and C is 3B over 4, multiply both sides by B. Let me zoom in a little bit here. They love getting rid of denominators. They obsess over that. Then we average these two. So this works out being 4B over 4 on the top, which is 1B, I meant to say. So the top ends up being just B. So 1/4 plus 3/4 B is 4/4 B, which is 1B over 2. Okay. Number 9, the median and mode are the same in which of the following? Okay, so the mode is the most repeated and the median is the middle. Well, there aren't any that are repeated in A. 14 is repeated in C, so that's the mode, but the median's 13. 11 is repeated, but the median's 13. So 12 is repeated and 12 is the median on 9. Problem 10. The range of set 1 is more than the range of set 2 by 1. So largest minus smallest. Make sure you're doing the largest minus the smallest. Sometimes they'll not write the numbers in order. Okay, consider the following statements below and indicate which one of the answer choices is true. The average height of 50 students can be calculated by adding the average heights of 2 sets of 25 students each, divided by 2. So the average height of each of 2 sets of 25 students can be used to calculate the average height of 50 students. Okay, so 2 only. You wouldn't, this has some error in it. So yeah, I had to pause and think for a moment. You have to divide the situation in 1 by 2 because you would be doubling when you're adding the average together. You'd have to divide it by 2 because the count is 2 there. All right, moving on. Problem 12, the smallest number in a data set is 5 and the range is 15. So what is the largest? So you would add the range to get to the right. So you're talking about 5 and then a bunch of numbers and then 20 is the largest. So the range would be 15. Problem 13, so here we go again with like a weighted average. So frequency times the weight plus frequency 2 times the weight plus frequency 3 times the weight over the sum of the frequencies. And then you get an average of 6. 14, another weighted average. So 6 hours at 60 miles per hour plus 9 hours over the sum of the hours. And then that would be the average speed. Okay, if x is the average of all the angles in a triangle, and y is the average of all the angles in a rectangle, so 60 plus 90 is 150. So it's a sum over the count. You want to understand that we're not necessarily talking about an equilateral triangle and a square. It's just the average angle measure in a triangle, which is kind of weird to think about. Problem 16. Which of the following could be the median number of cars owned by those surveyed? So 50, so this is at 50 here, this is at 40, and this is at 85. So you need to figure the middle. So 185 is the total. So what is the middle in that particular score? So if you have 93, how many are there? There's 1 through 92 here, and then 94 up through 185. And so that's 92 on the right, 92 on the left, and 1 in the middle. That's in the 93rd position. So we have to go to the 93rd position, which puts us in the 4 to the 6 car category there. So finding the middle of a data set is quite important in when you want to find the median. Sometimes you need to really work at it. Okay, 17, for a given set of data, which of the following is least affected by the addition of an outlier? So the median position, if you have a huge set of data, often you might get bumped, but that number will be very close to it. So that's often the least affected. Okay, so did at least 2 standard deviations more than the mean. So you add 2, if you're 2 to the left, which would be not so good, you would be at 54. The interquartile range of a data set with a lower quartile of 10 and an upper quartile of 22 is, so it's always Q3, that's this, minus Q1 when you do it. And it's really used to determine outlier boundaries, but we don't want to do outlier boundaries in this. We just want to do the IQR. Okay, 20, an opinion poll stated that 30% of citizens of Culver City will vote for Stacey as the new governor of their state. The margin of error of the poll is plus or minus 4% with a 95% confidence level. If the poll is conducted again, what is the least percent of votes that Stacey can expect to get? Okay, so plus or minus 4% margin of error at the 95% confidence level, which we didn't need to know. So the least 26, the most would be 34. Gotta love my 2 different colors of marker. Going on. Problem 21, standard deviation is the measure of the spread of data. So what data is more spread out? Set 2. And then set 2 does not have 2 modes. The mode is the most repeated value. Set 1 has a range of 105. That's not true. It has a range of 5. 22, the standard deviation of the data shown above is 15.6. The population, do not worry about that. You're not going to have to calculate it. So I'm going to kind of just skip over that problem. And problem 23. Okay, so the minimum temperature readings, let's get this in the city for 365 days are shown in the box plot. The range and interquartile range. So the range is the upper minus the lower. So about 70 minus 10-ish. And the IQR is, so this is Q1 minus, or Q3, 50 or so minus Q1, which is 30. And that makes 20. So 60 and 20. So that wraps up assignment 13. This is by far the more important of the two with statistics.